Hey guys, and welcome back. In today's video, I will be solving another popular SQL problem. So let's get right into it. Here, managers with at least 5 direct reports. Now we have a table employee. Now, if you look at the table schema, employee has 4 columns. We have the ID column, which is of type integer, the name, which is of type varchar, the department, which is of type varchar again, and manager ID, which is of type int. ID is the primary key, meaning column with unique values for this table. Each row of this table indicates the name of an employee, the department, and the ID of the manager. If manager ID is null, then the employee does not have a manager. No employee will be a manager of themselves. Now we are asked to write a solution to find managers with at least 5 direct reports. Return the result table in any order. The result format is in the following example. So let's take a look at the input table. Now we have the ID column, so these are the IDs, and then we have the names, the department, and then manager IDs. So we can see we have null and then who these people report to. So we can see that Dan, James, Amy, Annie, and Ron, they all report to John. So John is their manager. Now the output is John because John has at least 5 direct reports. So if you remember in one of the questions, we discussed that at least refers to greater than or equal to. So here John does have 5 direct reports. So Dan, James, Amy, Annie, Ron. There are 5 people. That's the reason why the output is John. So I hope you have understood the problem statement. Now let's go ahead and start solving the SQL query. Hey, so I just want to take a moment and explain a very important concept that's asked during the interviews, and that is a concept of cell joins. Of course, it's not as common as inner joins or left outer joins, but it is definitely there in the list. Self joins is a very important concept when you're working with a company. A lot of the queries do use subjoins. So if you observe the two tables here, we have a table employee and we have the table manager, and then we have the entries. Now if you observe the entries in the column names, it's all the same. The employee ID 1 2 3 4, employee names, manager IDs, employee ID, employee name, and manager ID. They're the exact same entries. So these two are essentially the same table. We are just referring to the same table by two different aliases, since we have to join them to each other. So what we're doing is we are joining them on the manager ID and the employee ID of the employee and manager table respectively. And this is the output that we get. So we get the employee ID with the employee name and the manager IDs and their manager names who they report to. So this is kind of like the logic that we have to follow in the problem that we're trying to solve. So let's go ahead and continue with the SQL query. So I hope you've understood the example that I showed you before. Now let's go ahead and start constructing a query. Now what I'm going to do is I'm going to put from employee as A, inner join employee as B. Hey, since we're joining both the tables to each other, I mean to itself, since we're joining both the table to itself, hey, so we can't use the same name for both our tables. That's because when you're extracting the columns, you will get an ambiguity error, and we don't want that. And that's the reason why we give an alias, we give two different aliases. So we're referring to our first table as A, and the same table which you're calling up, we're referring it to as B. So if you remember in the example that I showed you, we had, even though the entries and the columns are the exact same, but we refer to them as two different names. The first table was the employee and the other table was the managers. That's to prevent ambiguity. So I hope that makes sense. So now I'm going to select the column. Select a dot name as employee name for a reference, comma a dot manager ID as manager ID, comma b dot name as manager name, manager name, comma b dot ID as employee ID. So this is exactly what we want to achieve. Now we're going to add the primary foreign key condition, manager ID equals b dot ID. So let's run the query. Just give it a sec. All right. Here, so if you look here, we have the employee, the managers they report to, their manager names, and the ID of every employee. Okay, so this is exactly our output that we wanted. Now what you're going to do is we're going to put this within a CTE for code, since we need to use this table. Now we need to report the managers with at least 5 direct reports. So I'm going to write a condition here. So I'm going to put select. I'm going to put select manager ID. I'm going to put select. My bad. I'm going to put select manager name as name. Alright, comma. As a name as name, comma. No, comma. Count of. I need the employee IDs. Employee IDs. Employee IDs as counts from CTE, and I'm going to group them by the manager name. Manager name. So let's run the query. All right. So we have John. So you see like how John is the only manager who has counts greater than equal to 15 at least. So that's greater than or equal to 15. So it's John. So now what we can do is we can put this in. We can put this in a CTE. All right. And then we can write the final query. So select name from CT2 where counts is greater than equal to 5. My bad, equal to 5. So let's run the query. Voila. So it's done. Now the reason why I decided to write the query like this into different steps is so that you understand what I'm trying to do. Of course, if you have a better way and a more optimized way of writing the query, by all means go ahead with that, because that's another thing they look for in the interviews, like how well you are at optimizing your queries. That's a very, very important task to do. I'm writing the queries this way so that we understand why is it that we are writing a query, why is it that the logic is this way, and what do we do to arrive at the correct conclusion. So that is our main goal. So thank you for watching, and I'll see you in the next one. Thank you.